Okay, in these problems here, we want to decide whether the function is even or odd. So first, let's understand what we mean by an even function and an odd function. So first, even function is a function that looks like this. It is symmetric about the y-axis. So even function, it is symmetric around the y-axis. So the y-axis is like a mirror, and everything is the same, like an object and its image across that mirror. So even function is symmetric about the y-axis, which means basically if you have an x value here and on the other side we have the negative x value like 2 and negative 2, their output, their y value would be the same. So also it means that f of negative x is equal to f of x. So that's the algebraic meaning of the even function, and the graphical meaning is the symmetry about the y-axis. Another example, maybe this function also is symmetric about the y-axis. Look at the y-axis, looks like a mirror. Maybe this function, the v-shaped function, maybe a function like this. If we have exactly the same image here, so that's an even function. Maybe I didn't graph it well here. So that's the even function. So basically, you need to know this algebraic definition and this geometric definition. For the odd function, it is a similar idea. So we say that the function is an odd function if it is symmetric about the origin. Symmetric about the origin. The origin is 0, 0. So basically, the graph looks like this. So 0 here, like the mirror. So any point here has an image across the origin. Or maybe another graph is maybe this one, like this, across. It is symmetric across the origin, as we see here. Maybe this line, symmetric across the origin. So same thing with this line. And what is the algebraic definition of that? If we look at negative x here and x here, this is f of negative x, and f of x is here. So basically, f of x and f of negative x have different signs. So we can say that f of negative x is the negative value of f of x. So that's the algebraic definition here for the odd function. So back to this example. So to find whether the function is even, odd, or neither, you can do that graphically and algebraically. So algebraically, here for this function, I want to find f of x and f of negative x. If they are equal, then the function is even. If they are equal but have different signs, the function will be odd. So f of x obviously here is 2 over 3x minus 1 plus 1. And f of negative x means just replace x with negative x. So that would be 2/3 minus negative times negative x plus 1. So that is equal to negative 2 over 3 x plus 1. So as we see, f of x and f of negative x, they are not equal. So the function is not even. Also, f of negative x is not equal to negative f of x. They are not the same, so the function is not odd. So for the first function, this is neither. We can see that also graphically if we graph this with Desmos. The graph is here. Yeah, that's the graph. Look at the line here. It is not symmetric around the y-axis. So for example, if you pick this point, the point here, we don't see the point across the y-axis here and here. No, so the y-axis doesn't act like a mirror here. So obviously this is not even. Also, it is not symmetric across the origin, so it is not an odd function. Let's talk about the second one. So for this one, we need to know f of x, which is x plus 2 squared. And we need to know f of negative x. This is negative x plus 2 squared. Obviously, these are not the same. So the function is not even, which means it is not symmetric about the y-axis, as we will see in a second in the graph. Also, f of negative x is not equal to negative f of x. Not equal. So the function is not odd. So again, this function is neither. So we can see that graphically. If we go here, graph it, as we see here, the y-axis is not a symmetric. Is not the line of symmetry. Actually, the line of symmetry here is x equals negative 2. But so the y-axis is not the axis of symmetry, so this is not even, and this graph is not symmetric about the origin. So it is not odd as we've seen that algebraically. And finally, this one. So f of x is equal to absolute value of x minus x squared, and f of negative x. In this case, I need to replace x with negative x. But the absolute value of negative x, that's the absolute value of x. They are exactly the same. The absolute value of 3, the absolute value of negative 3, they are the same. And negative x squared means you multiply negative x by negative x. The answer is x squared. And as we've seen here, as we see here, f of x is exactly equal to f of negative x, and that's the definition of an even function, which means that this function is even. And graphically, if we graph it, we will see that it is symmetric about the y-axis as we see here. Look at the y-axis, it looks like a mirror. Every point on this graph has an image that is the same distance away from the y-axis. So we see that this is an even function.